In this video here, which will hopefully come out to be a relatively short one, we just want to make a few comments about electric potential versus electric potential energy, because they're not the same thing. In the first sense, they have different units here. Electric potential has the units of volts, which sounds very electricity, and electric potential energy has the good old units of joules, just like all energy does. So there's nothing different there. So let's just see if we can talk a little bit about their difference between them, because there is one, but they are related. Okay, so what we'll do is we're going to go back to that proton, which got itself stuck between plates of a capacitor like this. Okay, so what we know is that as the proton sits in between the plates of a capacitor like this, there's electric field lines going down like this, and let's make sure that proton is still there, and we know that electric field lines always point out of positive and into negative, so down like this, something like this, and there we go. This is a situation that it exists in between those parallel capacitor plates. So we know a couple things going to happen here. Is one, as is just sort of our stay consistent with the previous videos here, that the way we got the plates to charge up like this is with a 9-volt battery. So it looks like this, and it looks like this. There's a 9-volt battery. So what we know now is that there's a potential difference of 9 volts across these plates. For instance, if we got a voltmeter now, maybe at Home Depot or something like that, and we connected the positive lead up to this plate and the negative lead down to that plate, the number we'd see on the screen would be a nice 9 volts. That's what we'd measure there. Okay. And that's of course the V, that's the voltage right there. But we know a couple things now also, is that the proton, as it sits near this this negative plate here, doesn't have any potential energy. So the U at this point right here is 0. And I know it doesn't have any potential energy because it's going to be stuck against this plate here. This plate is negatively charged, and we know opposite charge attracts, so almost like it's stuck with glue or something like that. The proton just can't move because it's stuck there. But now if we take it and grab in our hand and pull it all the way up like this, keep pulling, keep pulling, keep pulling, keep pulling, until the proton is all the way up here at the top, now what we know now is the potential energy, so it has 0 joules down here, but when it makes it to the top, the potential energy up here is not 0. Let's just say not equal to 0 joules. It has some potential energy now, and I know it has potential energy because as I hold this in my hand, if I let go of it, guess what it's going to do? It's going to fly down and slam down and hit the negative plate. That's just like a ball that's at the very top of a hill like this. If the ball's up here at the top of the hill, say the hill is a distance h tall, it has a lot of potential energy. It has a non-zero potential energy up here because if I just give the ball a little nudge, it's going to go all the way down here to the bottom until it gets down here where it won't have any potential energy anymore. It has 0 joules down here at the bottom of the hill. These are some of those analogies with mechanics here that might make learning about potential a bit easier, but this is exactly what happens to the ball. It doesn't have any, it has a lot of potential energy up here because it's at the top of the hill, none down here at the bottom because it can't do anything when it's at the bottom unless it's pushed or pulled again. The proton behaves the same way. No potential energy down here when it's stuck up against this negative plate, but if I lift it up here and let it go, or if I just hold it here, it has a lot of potential energy because if I let it go, it'll fall down and slam again. So see, there's two ways of classifying the charge. We can say up here it has potential energy, that's U, that's in joules, but electrically we can also say it has some voltage, V, and that's in volts. I guess I should spell these things out here. That's in joules and volts. So there's two things that it has, but you see they're sort of the same. It seems like the proton has potential energy when it also is near this higher 9-volt plate. So it seems like it has potential energy when it also seems to have voltage. And down here at the bottom we say, well, it doesn't seem to have any voltage when it doesn't seem to have any potential energy either. So they sort of seem like they're the same. And indeed they are. So the key relation that you'd want to take out of this then is that something's change in potential energy is equal to the charge value itself times its change in voltage. This is sort of the key one right here. So that's a relationship sort of that you want to remember. It's extremely useful to have around for working textbook problems and so on, is that charge is equal to, potential energy is equal to charge times voltage. So this is your change in potential energy right here. This is your change in volts right here. And sort of what moderates or dictates the whole thing is the amount of charge in question. Because although we have just one proton sitting here, we could easily just bulk this thing up until we get a whole bunch, like a big ball full of positive charges, or a big ball full of positive charges here. That will definitely change its potential energy that it gets up there, but oddly it wouldn't change its just potential, because either way it's at 9 volts at the top plate or 0 volts down here. So that's a big difference between potential energy and potential, and that's why we tend to talk about potential in terms of volts more, because we're not always concerned, particularly when we get more macroscopic, about exactly how much charge is involved. So we're not so interested in the potential energies of charges, like exactly how many joules it has up here, but just knowing it's up near the 9 volt plate is good enough for our application. So that's sort of the difference right here. So this is just a little bit of a thing here about how two similar sounding terms here, just electric potential, which is in volts, and electric potential energy, which are in joules, are sort of related. They sort of measure about the same thing, but there is a charge moderating in them. They're sort of related, but they're kind of not also in the same way. But we sort of stick with voltage instead.